Hey guys, this is Mitch with Fine.CGI, and today we're going to talk about how to create a VOIP system inside of Godot in C#. So we're going to go through the process of setting up our scene. Then we're going to go and actually code up our VOIP system. We're going to talk about audio buses and how they work. We're going to talk about how to actually capture the audio. And we're going to jump into how to actually create the multiplayer elements. We're going to talk about how to do the RPCing. We're going to create a server. We're going to create a client. And then finally, we're going to talk a little bit about compression, because you can actually save a bit of data if you go through and compress the data just a little bit before you send it out. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing we need to do is we need to set up our nodes. Now, this node setup actually comes from somebody else. Now, they did a Reddit post. Their name is called Pass the Coding. They did a Reddit post talking about kind of how to do VOIP. So this tutorial is kind of an extension of this person's core idea with some changes on how we do a lot of the networking and things like that. So thank you to Pass the Coding for the basic inspiration for this tutorial. Now, when it comes to our node setup, we're actually going to go ahead and set up our microphone input. Now, to do microphone input, it's actually relatively simple. First things first, we need to go to project settings. We need to turn on advanced settings, and we need to come in here and type input and go under audio driver, enable input, and we will turn that on. We'll click save and reset, and that's going to make Godot go ahead and reset. Now I'm going to snap that into my recording section here, and what we're going to do is we're going to go ahead and set up our audio manager. So we'll go to other node, we'll type node, we'll hit enter. We're going to name this audio manager like that. We're going to right click, add a child node, and we need to have some way to capture your input. Right? So when you talk into the microphone, you need to interface with the Godot audio system to be able to capture your voice, right? So that means we're going to need some way to input that information. So if we type audio, there is an audio stream player right here. So we'll double click on that, and we're going to name it input like that. Now, when we go into our input, you can see here we have a bunch of settings, right? And down here we have what's called a bus. Now, there's only one option. And we need to have more than just one bus, because we need to have a bus to be able to handle our microphone input. And then we also need a bus to be able to listen to it, right? Now, Godot is a little on the funky side, but the way you control audio is you click on the audio tab down here. Now, I'm going to add two buses, and I'll explain why in a second. I'm going to name one mute bus, and I'm going to name the other one record. Now on the record bus, I'm going to click on add effect, and I'm going to add a capture effect. That's going to allow me to capture my microphone. So this is where if you were to do any equalizing or vibrato or high pass filters or something like that, that's what this is for. So the nice thing is you could come in here and add in limiter here, and that can help stop people from clipping their microphone. Or you could add in something like a compressor, which would also help with that. Or you could, add some delay or distortion to make the person sound different. Now, in my case, I'm going to stick with the capture, and that's fine. Now, if we were to play our game, what would happen is you would hear your microphone through your headset. So we want to mute that, right? But we can't just click mute, because if we turn on mute on this bus, what's going to happen is it's going to mute our microphone input. And that's where the mute bus comes in. So we're going to click on mute on this guy, and it's going to go ahead and mute our record bus. Now we have to pipe our record bus through our mute bus. So how do we do that? Well, thankfully, Godot makes it relatively simple. We can just click on master and click on mute bus, and that's going to go ahead and make it so that our record bus goes through our mute bus and it links them together. So it kind of links it like a chain. So you can see this guy's connected to this guy's connected to this guy, more or less. And that's the basis on how that works. Now, once we have this, we're pretty much good to go to close our audio tab. Over here on the input side, we can go ahead and click on record, and that's going to tie our input to this bus, if that makes sense, to this microphone input bus. Now, once we have this, we could basically just right click our audio manager, attach a script, and let's add in a C# audio manager.cs. We're going to go ahead and hit create, and it's going to open up VS Code. Now I'm going to snap this guy to be full screen for us, and we'll go ahead and code out our audio bus. We're going to approach this relatively simple, but we are going to need to do a little bit more work than if we were to do this in GDScript, and that's because there's some funky types and things like that we have to work with. So first things first, we need to set up a way to set up our audio. So when a user actually gets spawned into the world for VOIP, you need to basically set up their audio bus and set everything up and get it ready. So we'll go ahead and do that. So we'll say public void set up audio like that. I'm going to pass in a long, and I'm going to pass in ID. Now, the reason why I'm passing in an ID is because when we set up our audio, we need to know who is the person that owns that node. Because this is a multiplayer instance, that node is going to be controlling what person is speaking and where the information goes. So that's why we're actually doing it this way. Now, what we'll do is we'll need to get some global references. So let's head up here and let's say private audio stream player input. We'll also need a private int index. And since this is private, we should probably make this a lowercase I. That just helps with keeping naming conventions and standards available. We're going to need to have what's called an effect. So we'll say private audio effect capture effect. Then we'll come in here and add in a way to play back our audio. So private audio stream generator playback. And I think that will do it for right directly now. Now, what are these guys for? So this is our input. So this is us when we're talking, what we're inputting into. Our index is our bus index. Now, that's something that I will explain in a minute, but it's basically used for determining which index is our input parameter. We have an audio effect capture here, which is an effect that is actually the capture of our voice. So this houses this guy here, and basically we're going to use this as like a way to capture our voice. And then we have the thing that we're going to use to play back our voice after it's been captured and sent through the wire. So once it's been sent out to everyone, and then how they're going to play it. So that's what this one's for. Now, one other thing that we're going to need is we're going to need to get a reference to our actual playback node. So with this, we need to actually have some way to reference that node or go and find that node. And that node can technically exist anywhere in the project. So we're going to want to make sure that we actually set this up correctly. So I'm going to pass in a public node path, and I'm going to call it audio output path, and I'm going to say get semicolon set semicolon, and there we go. Now that's just going to allow us to have that flexibility that we're looking for, so that way we can reference nodes outside of our node group and still maintain that flexibility. So we'll come down to set up audio, and we will actually set up our audio. So first things first, we need to set our input equal to something. So we'll say input is equal to get node, and we'll pass in an audio stream player, and we'll call it input like that. What that's going to do is that's going to fetch our input node right here. So that way we actually can grab that and set this object as a reference. And then we'll want to pull back our input. So we'll say input.stream is equal to new audio stream microphone like that. We're going to want to play our input, and I'll explain what that means in a second. We're going to want to grab our index. So index is equal to audio server dot get bus index, and we're going to want to pass in some kind of name. Now our bus's name is record, If you remember, we put it right here. Our bus's name right here is record. So we'll put that guy in, and that'll allow us to have that index. And then we can say effect is equal to audio server dot get bus effect. We'll pass in the index and we'll pass in 0. Now you'll notice that there is an underline here. Cannot implicitly convert type audio effect to Godot audio effect capture. An explicit conversion exists. Are you missing a cast? And what that means is that we need to cast our audio effect as an audio effect capture. So that way we're telling C#, hey, this is an audio effect capture. It's a microphone capture. And now we have to play back our audio because we have a way to capture our audio, right? Right here, we're pulling all this back. We need to be able to capture that audio. So we'll say playback is equal to get node. And this is where things get a little weird. So we have a choice on what type of node we want to bring back. If you're doing spatial audio like a 3D game, you're going to want to return an audio stream player 3D. If you're doing a 2D game and you want spatial audio, you're going to want to do an audio stream player 2D. But if you're doing a non-positional audio VOIP system, then you're going to want to do an audio stream player. Now, in my case, I don't really care about positional audio, so I'm going to go ahead and use an audio stream player 2D like that, but use whichever one you would like. And then we'll pass in a path. Now, in our case, we already have a path set up right here, audio output path. So audio output path dot get stream playback like that. Now you'll see it's mad. It says, hey, you cannot convert type audio stream playback to Godot audio stream generator playback. An explicit conversion exists. And that means that we need to cast it as an audio stream generator playback because this has a lot of the same properties, but it doesn't quite match up exactly with what C# is looking for because C# is so type safe. Sometimes you have to force the conversion of an object instead of doing it as like a soft conversion. You have to do a hard conversion. So that's what we're doing right here. So at this point, we have our setup audio basically done. Right here, we're pulling back our input. That's our microphone input. We're creating a new stream on that input object, which is our microphone. So this is the node that is going to hold our microphone input. This is us actually pulling that microphone input and creating it. This is starting that capture of that microphone. This is setting which bus we're recording it on, which is the record bus. And then this is pulling back that effect to where we're going to load that data. So think of it kind of like a bucket, right? We're taking all of our data. We're actually creating our microphone right here. We're grabbing our bucket and then we're throwing that data into that bucket, that bus, if that makes sense. So that's basically what's going on here. And then we're just setting up which node we're going to play back to when we do our stuff. Now, at this point, we basically have to fetch our microphone information. Now, this is actually going to be a little bit of a painful setup. So forgive me, and I will do my best to explain it. But basically, we need to process our microphone every single frame. So we need to actually set it up so that we can process our microphone every frame so we can pull the data as the person's talking. So we could do that inside of a process right here. But if we do that, it's going to look really dirty. So what I'm going to do is I'm going to pass in a function called process mic, and I'm going to come down here and create a function specifically to handle this, just so that it's separate from everything else and it kind of abstracts some of our logic here. So when we're processing our microphone, what we need to do is we need to get back that data. So first things first, we need to come up and say var stereo data is equal to effect.get buffer, and we'll pass in our effect.get frames available like that. So what this is doing is it's getting our effects buffer. So when you speak, what happens is that data gets shoved into your audio effect buffer. there's like a bucket of information where it's holding on to that data. So what we're doing is we're pulling back that buffer into a data right here. This is actually your stereo data. So this is going to be the words that you're speaking, but in vector 2 format. And get frames available here. When you're grabbing data from a buffer, you're basically saying, hey, I want you to grab the data. But how much data do you want to grab? Well, you have to inform it how much data you want to take. So in my case, I'm going to pull back the entire buffer. So all of the data that bucket has, I'm going to just pull it all into this variable right here. From here, I'm going to say if our stereo data.length is greater than 0. So if it has any data at all, because if they don't have a microphone plugged in, you don't want to try to RPC data that's not there. So that's what that's for. And then we're going to basically create what's called a float array of that data. Now, we could just RPC this data over. You could literally just say like RPC and then, let's say send data, comma, the data that we sent. So our stereo data. But since your data is mono, you don't want to just send data across the wire that could be compressed. So that's why if you do it this way, you're going to be doubling the amount of data that you send across the wire. So what we'll do is we'll come in here and we'll break it apart. So we'll come in here and we'll say var data is equal to new float array, and we're going to make it the size of our stereo data dot length. Because when you create an array, it needs to be the exact length of the stuff that you're doing. Because if it's not, then you'll get a overflow of your actual array. So we'll do that. And then we'll basically just loop through our stereo data. So for int I is equal to 0, I is less than stereo data dot length, I plus plus. And then we'll basically loop through our data and just make sure that it's good to go. Now, I do have a little bit of a problem here with formatting. There we go. So first things first, when we want to convert our data to mono, all we have to do is say var value is equal to stereo data bracket bracket I dot x plus stereo data bracket bracket I dot y divided by 2. And what this is going to do is it's going to take an average of these two vectors here. That way we're not losing data from one side. So just in case somebody somehow has positional audio within their microphone, it's not going to sound all broken and destroyed because we're averaging up the data and just making sure that it's consistent. And from here, we could basically just say data bracket bracket I is equal to value. And then we could RPC that data. Now, of course, this is kind of pseudocode because we don't actually have the RPC set up, but that would be basically how we'd process our data. But something that we should do, but a case that we should look at is what if a person's not speaking at all? Do we send over empty data? Do we not send over empty data? How should we handle that? Well, you should always send over data if it's available. But if there's no data available, then you shouldn't send it over. So let's come in here and set up an amplitude system. So we'll come in here and say float max amplitude is equal to 00f, like that. And then we could just come in here and say max amplitude, amplitude, not T, there we go. Amplitude is equal to math.max value, comma, max amplitude, like that. So basically, if it has data in it, it should pass over, right? Then we can come in here and basically say if max amplitude is greater than some kind of threshold. So let's actually come up here and create an exported variable for that. So we'll export that out. Public float input threshold. We'll come down here and say input threshold like that. And if it is less than our input threshold, then we could just return like that. Else, we know that we have data. We have something that's usable. So we'll come in and we'll send out that data. And there we go. Simple enough. Now, we should probably default our input threshold to something, some kind of value. So I'm going to set it to 0.005 float. I think that will probably work, but we can always make adjustments inside of our editor. Now, here we're RPCing our send data, and we don't actually have that function. So let's head down here and create that. So we'll say private void send data. And because we're passing in a float, we'll go ahead and pass in a float array as well. We'll call it data like that. Now, inside of here, what we're going to want to do is we're going to want to hold on to all of that data. And when a person RPCs that data over, we can't just say, hey, let's play this audio immediately, because the audio may or may not be all the way in with that one packet, right? So when I speak to you through this, these things get broken up into chunks of data. And you have to make sure that all the chunks of data are there before you can just play the information. So what we need to do is we need to create basically like a little buffer to work with. So what we'll do is we'll create a variable up here called a receive buffer. So we'll say private array bracket bracket float like that. And we'll type receive buffer. We're going to make that equal to a new Godot.collections.array. And we'll make that into a float type. And the reason why I'm converting it to a Godot collections array, which you can see here, it's a little on the confused side. So I'm going to come in here and just paste this guy in here like that. Now, the reason why we're doing a Godot collections array versus a C# array is because the buffer that the audio player is expecting is going to be a Godot collections array. So we're going to go ahead and use their own array. Now, we need to basically add that to our array. So we'll come down here to our send data. We'll type receive buffer dot add range, and we'll go ahead and add in our data like that. And that'll basically pass a data to our receive buffer. So now at this point, our data is in our receive buffer, right? And we're basically RPCing our data across. We're putting it to our buffer. But our function is not an RPC-able function, right? It's not a multiplayer function just yet. So let's change that. Let's make it into something that actually can be used for multiplayer. So we'll say bracket bracket RPC, and we can pass in a bunch of parameters. Now, by default, it sets it to authority. It sets it to call local as false. It sets it to a base transfer channel, and the type of transfer mode that it defaults to is reliable. So we need to make sure we change some of these things. So first things first, let's change our mode. So we'll say mode space multiplayer API dot RPC mode dot any peer. And that basically just means anybody can call this, and it's going to send it to everyone that we're connected to. So if the server calls it, it goes to everyone. If a peer calls it, it goes to everyone, basically. If we were to set this to authority, only the server can call this function and it'll send data. So that's something to keep in mind. Next, we're going to set our call local. So call local, we're going to make that equal to false. And the reason why is because we don't want to hear ourselves when we're talking, right? We only want to hear other people and hear them talk. So that's the reason why we're setting it that way. Then we'll say transfer mode is equal to multiplayer peer transferred enum dot, and we're going to say unreliable. And the reason why is because reliable requires basically twice the bandwidth or twice the time to have communication. Unreliable will just send it out and not wait for a response, but reliable will wait for a response. So if you think about it, if you're playing with a friend and you guys both have 100 millisecond ping, what's going to happen is you're going to say a word. It's going to wait 100 milliseconds to get to him. And then it's going to come back to you and say, okay, I've sent the message. Now you can say the next word, and then it'll go 100 milliseconds and then 100 milliseconds. Whereas with Unreliable, you basically just throw all the words out to the person, and then if they catch it, they catch it, and if they don't, then they don't, and that's totally fine. So that's basically the big difference. Now, of course, if you want to do Unreliable ordered, that's totally fine, but in my case, I'll just go with Unreliable because it is slightly faster, and it's not critical if something gets dropped or something like that. It's not a big deal if some of the words kind of skip or have that stutter feel to it when you're talking. Now, once we have a buffer, we basically are good to get started playing our sounds. So the best way to do that is to do that within our process. So we'll come in here and just say process voice like that. We'll come down here, private void process voice like that. And then we'll basically set up our voice processing system. Now, this should be relatively easy. Basically, all we're going to do is we're going to check if our receive buffer dot count is less than or equal to 0. And if so, then we'll go ahead and return. Else, we know that we have some data that we can play. So we'll say for int I is equal to 0. I is less than math.min. So we're going to take the minimum of our playback dot get frames available, comma, receive buffer dot count. And then I plus plus. Now what this is doing is it's basically saying for whichever one has the least amount of information, either our receive buffer or our frames that are available, then we can actually play our information. Now, the reason why we're doing this is because we don't want to go over our buffer if we already have information in our playback buffer. So think of it kind of like this. When you put stuff into your buffer, if it's still playing and additional information comes into the buffer, you're going to want to make sure that this data gets played first before it starts throwing this data into the actual buffer. It's just a way to kind of keep your buffer from overriding your playing buffer, if that makes sense. So we'll say playback dot push frame new vector 2, and we'll pass in our receive buffer bracket bracket 0, comma receive buffer bracket bracket 0. And then we'll go ahead and say receive buffer dot remove at parentheses 0. And what that's going to do is it's basically going to push that data into our playback and get it ready to play, right? And once that pushed frame has been put into the buffer, into the playback buffer, then we can basically remove it from our receive buffer, if that makes sense. And at this point, we basically have everything done. Now, this isn't the multiplayer version of this, so in theory, we should probably hear ourselves if we actually set up the rest of this. But this is pretty much everything. Now, if we go to process mic and we comment out our send data and we just call it instead, like this, and we just pass in our data, that'll allow us to actually hear it locally, so that way we can actually hear what our stuff sounds like. So I'm going to go into Godot here. I'm going to close this. I'm going to hit Control S and add in audio manager.tscn. I'm going to create a new scene. I'm going to create a 2D scene. I'm going to right click. I'm going to add in my audio manager.tscn. I'm going to right click, add in a child node, and let's add in an audio stream player 2D. Because if you remember right here in our setup audio, we said that it was going to be an audio stream player 2D. So we need to make sure that that matches. So there we go. We're going to go ahead and click on our audio. We're going to compile our project to make sure everything compiles. And then you'll see here that we have our input threshold and our audio output path. So I'm going to click assign. I'm going to assign it to my audio stream player. Click that guy, and then there we go. Now, inside of here, we need to do some legwork. So if you remember, inside of here, we actually said we had an audio stream generator playback. Well, that's a very specific node. Inside of our stream right here, we called that out, get stream playback. So we're getting this stream right here. And we need to basically set up an audio stream generator for us to do that playback. And I'm going to change the mix rate to 4800, and I'll explain why in a minute, but we'll do that. Now I'm going to set this as character.tscn, and I'm going to click on playing, right? So by default, it's going to play, and it's going to play on the buffer on the bus master. Now, of course, you can have it play on whichever bus you want, but in my case, I'm going to choose master because that's the bus that I'm using for this use case. Now, the reason why we checked playing is because we want it to play audio on startup. Now, if we go ahead and hit play, in theory, we should be able to hear ourselves. So if I talk, well, it definitely did not work. We have a bunch of errors. Object reference not set to an instance of an object. So if you look, it's mad because of our effect, it looks like. So if we take a look, 41, yes. So it's mad about our effect. So our effect might be null. So let me hit stop. And actually, I think what I'll do is I'll hit play. And what I'll do is I will open up my audio manager. I'm going to hit Control-Shift-P, and I will type debug attach. And I will do attach to a .NET 5 or .NET Core process. And I'm going to type Godot, and I'm going to pick the bottom one. Yes, because if you hover over it, which I'm pointing and you can't really see it, but right at the bottom right of this little pop-up, it says res character.tscn. So I know that that's the correct one. So I'm going to click on that, and you'll see that it's going to attach me, and I'm going to drop a breakpoint right here. So we can see what it's mad about. So if we hover over effect, effect is null. So okay, so we know that that part is null. That means that our setup audio isn't being ran, which is fine, and that makes sense because I didn't put it up here. So we'll say set up audio, and we'll pass in a 1 currently because I set this up for multiplayer, but we haven't quite set it up fully for multiplayer just yet. So that's the reason why we're having problems. So I'm going to go ahead and put it right here as a default value of 1, and then we're going to detach and refresh. Now, in theory, we should hear ourselves talking, which we don't. So that's never a good sign. We still have object reference not set to an instance of an object, and this time it's here instead of here. So let's hit Control-Shift-P, attach Godot. Let's click on this guy, and let's see what it's doing. So playback. Playback is null. So that means right here, our audio output path, is that null? Public node path, this. Audio output path. It is correct. It has data. So that's fine. So for some reason, our playback came back null. So my guesstimate is that we might need to do a 2-step solution here. So let's go in here and say var player is equal to, and then we'll go ahead and fetch back our player like this. We'll pull all this back like so. And then we'll do a check if player is an audio stream generator playback, then we'll cast it as a playback. Because sometimes things get a little wonky, so we'll go ahead and try that. And then instead of doing a audio stream generator playback, let's just go player as audio stream generator playback, like that. Let's see if that works. I don't know if it's going to, but it might, so we can try that. But basically what I think is going on is it's getting the stream playback, but it's casting it incorrectly here, basically. And because it's casting it incorrectly here, it's completely bricking it, is what I'm thinking is going on. So we're going to try that and see if that works. So we'll come in here, we'll hit play. Let's try this one more time. So in theory, nope, it's still mad at me. My guess is playback is still dead. So if we take a look, this has generator. Okay, so I think I figured out what it is. So basically in our audio stream, somehow this got turned off or something, but the autoplay wasn't set to on. And the other thing that I did that was a slight change was that instead of going through and doing that if statement, I basically just immediately cast it as that. Now you'll notice that my mix rate is set to 44. Don't worry, that's intentional, and I'll show you why. So if I hit play, you'll notice, hopefully, that you can hear me talk. Now, something that you'll notice is that my voice sounds super deep. And the reason why is because of the mix rate. So if you set this mix rate really low, then it's going to elongate that talk or those words, if that makes sense, if that data. So if I come in here and I shut this off and I make this go down to something like, 8,000, right? And I hit play, it's going to sound more or less like a monster. And that's kind of some ways that you could create some really cool monster effects if you wanted to. But that's kind of how this works. So just be sure to set this to something proper. Now, in my case, it's 4,800, and I feel like 4,800 has worked for most people that I know, so this should be a good default value to have. So if I hit play on that, you'll notice that it sounds pretty much exactly like me. And that's because this is what the mix rate I use is. So it's pretty much perfect. Now, looking at our code here, basically, we have pretty much everything that we need. All we need to do is basically set up our networking and we're good to go. So if we change this from send data to RPC send data, now all we have to do is basically go in and create our multiplayer section of our tutorial. Now, I'm going to do some pre-work here so that way we can actually make this work without, so that way if you want to leave before we do the networking section and just take the actual code, that's totally fine. So what we'll do before you guys drop off is if we come in here, you can see in setup audio, we need to change this to a multiplayer setup. So first things first, we need to set this node's multiplayer authority. So we'll say set multiplayer authority, and we'll pass in that ID. So we'll pass an ID like that. Now you'll notice that there is a slight error. It says, hey, cannot convert long to int. So what we'll do is we'll say convert dot to int 32 parentheses and parentheses, just like that. And then we don't want our microphone to work if we are not the host of the machine. So we'll say if is multiplayer authority, then let's do all of this bit of code here. And the reason why is because you don't want your microphone to get recorded if they are not the multiplayer authority, right? If you're not the multiplayer authority, you're only going to want to listen to other people's audio recordings. And that means also up here in process, we need to say if is multiplayer authority, then go ahead and process microphone like that. So at this point, we need to actually go and set up our multiplayer. So if you already have your multiplayer all set up and everything's done, then at this point, you guys should be good to go. Just make sure that when you instance your player that you run setup audio with your proper ID, and then everything should be fine. But if you haven't set up a multiplayer, let's go ahead and do that right now. So if we head over here into Godot, I'm going to right click, rename this as character. That way it just matches up with my scene's name right here. So that way we have a consistency there. And what I'm going to do is I'm going to click on scene, new scene, and I'm going to create a node scene. Now I'm going to right click, add a child node. Let's add in a node, and then let's duplicate that node. I'm going to make one client, and I'm going to make one server. Now, this is not how you do this for a production level. This is more for just testing and demonstration. So just keep that in mind. Now, let's go ahead and right click our client, add in a child node. Let's add in a button because we're going to need to be able to connect to our project. So we'll do that. And then we'll duplicate that button, put it underneath our server, and then we'll drag it over here. So we'll call this host, and we'll call this host, and then connect, and connect like that. There we go. And now we need to basically build out our server and client code. So what I'm going to do is I'm going to right click my server, attach a script, and I'm going to call it server.cs. Now, thankfully, this should be relatively quick to put together. So what we're going to do is basically when the host button is pressed, it's going to go ahead and start our server. So if we head back to our project here, we click on host, click on node, double click on button down. We're going to hit Control A, Control C. We're going to connect that, and then we'll come in here and say private void paste like that. And then we'll be able to set up our host code. Now, when we want to set up our host code, all we need to do is we need to set up a multiplayer peer. So I'll come up here and I'll say private enet multiplayer peer is equal to a new enet multiplayer peer. And then since we're up here, since our host is going to have a VoIP instance, let's go ahead and set up our player scene. So we'll hit bracket export public packed scene and player scene like that. And I'm going to say get semicolon set semicolon. And then we'll also set a Boolean. So we'll say private bool server is ready like that. And that's just so that way we can know if our server is ready. Now on our host button down, it's going to be really simple on how to set this up. First, we're going to check to see, first we're going to actually create our server. So var error is equal to peer dot create server. And then we get to choose our port. Now in my case, I always do 8, 9, 10. It's just a really easy port to use. So that's the port I like to use. Then we're going to check if there's any errors. So if error does not equal error.ok, then we can say gd.print server has failed to start plus our error like that. Then once we have our server created, we need to set our multiplayer peer as that server. So multiplayer.set peer, multiplayer peer is equal to peer like that. And that's basically going to set our multiplayer instance to that specific peer. And once we have that, we are able to instance our player scene. So I'm going to go and do that. So I'll say node player is equal to player scene dot instantiate like that. And then we have to put it as a child of something. So what I'm going to do is I'm going to go into here. I'm going to make a child for that. So I'll add in a child node. And I'll add in a node. And I'm just going to call this spawn player spawn location. And basically what we'll do is we'll come up here and do exactly what we did earlier. We'll hit bracket export, and then we'll say public node path spawn location like that. We'll scroll down here and we'll say get tree dot get node bracket node, because it's type node, spawn location dot add child bracket player like that. And then we're going to set the player name equal to 1 like that. And then we'll say player.getNode audio manager dot setup audio, and we're going to pass in 1 for the value for the ID. And then finally we'll say server is ready is equal to true. Now the reason why I have this server is ready is because up here in our process we're going to need to pull our peer so that way we can keep that connection up. Just like that. Now, basically, what is this doing? So what we're doing is we're creating a server, and then we're checking to see if we have any errors. We're setting our multiplayer peer as our server. So we're basically saying, hey, I am the server, set my global Godot multiplayer to that server, and then we're instancing the server's node. Now, if you don't want your server to actually care about the information, you can choose not to do this, but in my case, I'm going to go ahead and do that. And now all we have to do is do the client side. So this is pretty much all we need to do to get our server to work. So if we head back to Godot real quick, we go to our client, right click, attach a script, call it client.cs, go back, click on our connect on button down, copy it, click on our client, connect, and then come in here and do the exact same thing. So public, void, paste, bracket, like that. And then we basically need to copy our server pretty much almost the exact same. So we can come up here, grab pretty much all of this, come into our client, paste. We can come into our on connect button down. We can say peer dot create client like that. And then we can choose our IP address. In my case, I'm going to do 127.0.0.1, comma 8910. There we go. And then all we have to do is we need to set our multiplayer peer, just like previously. So multiplayer peer is equal to peer. And then we need to instantiate our player node, just like we did before. So we'll go to our server. Basically, we'll just kind of copy this. Really, we could have copied all of this and would have been fine. So we'll just copy and paste that guy in here. And instead of doing player.name is equal to 1, let's change that to multiplayer.getUniqueID .toString, like that. And then we'll do the same thing, but for the setup audio. So we'll paste that guy in there. And instead of doing toString, we'll just do getUniqueID. And instead of server is ready, because we have servers ready up here, we should do client connected, and we'll copy that guy, paste it like that, and then we'll come into our process and say if client connected, then we'll go ahead and hit peer.pull like that. There we go. Now, one thing that is different between our server and our client, because really we could have just kept this as one script, right? We could have just had our server and client code kind of combined. But something that we're going to need to do that's different is we need to come up here and do multiplayer dot peer connected plus equals peer connected. And what this is going to do is it's going to connect our multiplayer peer connected signal to a function down here that we're going to have to create. We'll have to do the same thing for disconnected as well. So we'll do that and disconnected. Now you'll notice that we have little squiggly lines underneath these guys. So what we have to do is we need to make those functions. So we just click here, quick fix, generate method, click this guy, quick fix, generate method, and there we go. Now when a peer disconnects, we don't really need to do anything, but what we can do is just type gd.print quote player disconnected plus id.toString like that. There we go. And then we can basically leave it at that. For peer connected, on the other hand, we need to come in and kind of handle some additional stuff. So first things first, we'll say peer connected. So we'll pass that in and say connected. There we go. And then we need to come in and basically spawn a player scene. So one of these guys. So I'll just copy this guy right here. paste, and I will say the name is the ID, like that, and the setup audio is ID. And that's pretty much all we need to do for that. Now, in theory, this should just work. Now, hopefully at least, but it never goes that way, so we'll see. So what we'll do is we'll head back to Godot real quick. We'll hit the build icon to build our project. And now, if we click on our client, you'll see that we have a player scene and a spawn location. So for spawn location, we're going to set player spawn location. And for our player scene, we'll drop in our character. And same thing for our server. So we'll assign our player spawn location, and we'll drop in our player scene as well. And I'm going to Control S and put this as test scene.tscn. And I'm going to hit play. I'm going to click host, and I'm going to click connect. And, well, nothing has happened. So what's going on? Well, you can't have two multiplayer nodes on the same Godot instance. You need to have one. So to mitigate that, what we need to do is we need to go into debug, run multiple instances, and run two instances. Then if we hit play, we can click host, and then we can click connect. Now the first thing you'll notice is we have a bunch of debugging errors. And second thing you'll notice is that it's actually working. We're able to talk to each other. And you'll hear me about 2 times, I would say. Now, I'm going to mute this because it's really annoying, I'm sure, to hear 3 of me. So I'm going to click on the debugger, and let's take a look at it. So it looks like it's mad because our multiplayer instance isn't currently active. So our Godot multiplayer peer client process is having an issue. So it's saying that this peer is not currently connected during its process, but it looks like it is. So let me refresh this, and let's just see if it's funkiness or if it's actual problems. And it looks like it's an actual problem because you can see that we're getting it again. So that's not great. So the multiplayer instance isn't currently active. That means that for some reason, our code isn't quite correct. But on the flip side, in our output, we have connected one and connected this. So our code is connecting. But for some reason, our multiplayer instance here I think it's because of this right here. So let's go ahead and get rid of that, because I wonder if it's because the peer is getting connected, so therefore it's throwing this into a loop, which is making it confused. So let's try getting rid of that, hitting play, and let's see what that does. So I'm going to hit host, and I'm going to click connect, and that has solved my issue. You can see we're not getting any errors in our console. Now, I can hear myself twice, so I'm going to go ahead and hit stop because it's throwing my train of thought off. But at this point, you're basically good. Everything's working. But here's something that's interesting. So if we go into our network profile and we click start and we hit play and we host and run our game, if I come in here and I talk while we're doing our network profile, you should see here we're passing about 150 kbps per second. Now, if I stop talking, you'll see that the data has dropped drastically. So that's good news, but we could actually make this better. So something that Godot does better than C# is it handles the voice data better than C#. And the reason for that is because if we come over here and we take a look at this, we're using a float array in our audio manager. So if we come down here, you can see we're using a float array. So what that's doing is it's basically saying, okay, this is just data, we're going to send it, right? But And Godot does some basic compression on top of it to make it a little bit more efficient, but it's not the same as a packed float array. So we need to do a little bit more cleanup to make our stuff a bit more efficient. So in order to do some compression, let's come down here and create two functions. So we'll say public byte array compress float array. And I'm going to pass in a float, float, bracket, float array, like that. And basically what we can do is we can come in here and more or less do a block copy and then compress our data. So in order to do that, what we'll do is we'll say byte array is equal to a new byte bracket float array dot length multiplied by 4. And that's basically going to initialize a new byte array, which is the size of our float array multiplied by 4. So it's 4 times the size. And the reason why we're multiplying by 4 is because that's basically the difference in size between a byte and a float, if that makes sense. And then we're going to do a buffer block copy. So we'll say buffer.block copy float array, comma, 0, comma, byte array, comma, 0, comma, byte array dot length. And that's basically going to copy everything from our float array to our byte array. And then we can come in and basically compress that data. So using var memory stream is equal to a new memory stream, like that. Then we need to get our actual gzip stream. So we'll say using var gzip stream is equal to a new gzip stream. We'll pass in our memory stream, and then we'll pass in our compression mode. So we'll say compress. Now you can also pass in, if you look at these other things, you can also pass in compression levels and things like that as well. In my case, I'm just going to pass in the compression mode, and that's it. So we'll just pass that in. And then we'll say gzip stream dot write byte array, comma, 0, comma, byte array dot length, like that. And then we'll go ahead and return that information. So return memory stream dot to array. So what is all this doing? Well, basically what it's doing, it's creating a new byte array. It's copying our float array to our byte array, and then it's coming in and it's using gzip to actually write and compress that data to a memory stream, if that makes sense. And then all we need to do is just return it, and then that's it. It's compressed. And now we can do the same thing, but the opposite. So public float array decompress float array, and we'll put byte bracket compressed array. And I'm going to show you a way to use using. So I don't know if you've ever used using before, but using is basically creating a scope so that anything that's inside of this little bit will get disposed of, regardless of if it airs out or anything. So that's kind of the whole purpose of using. So everything in here will get released as soon as it's done. So it's a little bit better off to use using in this specific use case. But you don't need to use these brackets all of the time. What you can do is you can actually come in and say using var memory stream is equal to a new memory stream and pass in that compressed array. Then you can come in and say using var gzip stream is equal to a new gzip stream. We could pass in our memory stream, and we could pass in our compression mode. So we'll pass in decompress. And then we can pass in using var result stream is equal to a new memory stream. Like that. And then we can add in our brackets. And this is equivalent to basically doing this right here. And so now we can basically go gzip stream dot copy to result stream, like that. And then we can create a new byte array. We'll call it byte array is equal to result stream dot to array. And then we can create a float array, which is equal to a new float array that is the size of our byte array dot length divided by 4. And then we can say buffer dot block copy byte array comma 0, because that's our offset, comma float array comma 0, because that's again our offset, and then our count, which is our byte array dot length. There we go. And then we can return our float array. Now, what this does is it basically says, okay, we have a memory stream, or we're creating a memory stream from our compressed array. We're taking that memory stream and we're decompressing it into a gzip stream. And then we're basically pulling this result stream, and then we're basically creating this result stream and then copying it into that result stream. So we're copying it into a memory stream. So we're taking a memory stream, we're decompressing it, putting it into a new memory stream, and then we're dropping it into an array. And then we're creating a float array, copying the data from our byte array to our float array, and then returning that float array. And that's basically how it works in a nutshell. Now, once we have this, we can basically come in, change this to byte array, come in here and say decompress float array, pass in our data like that, and then we can come up here to where we are processing our microphone, and we can say space compress float array and pass in our data like that. Now, in theory, this should be more efficient, so we'll see if that works. So we'll hit play. We'll take a look at our network profile. Hopefully it will be better. We'll hit host, we'll hit connect, and we'll go over to our debugger. Let's take a look at our network profiler, and I'll start talking, and you'll see that we cut a little bit over 20 or 30 kilobytes off. So it can make it slightly more efficient, but remember that there is a cost to doing it this way. So you can see that it did cut off about 20 or so, maybe a little bit more, depending on how much data we're passing across. But by doing this compression, we are going to introduce a little bit of latency and a little bit of audio quality degradation. So just keep that in mind. Now, obviously you couldn't hear me because I didn't have my desktop audio going, but it did work. You could hear us and you could hear yourself. And for, I guess, to prove it, I will show you guys. It does work. Now, I don't really like hearing myself, so I'm going to stop that real quick. But that's pretty much how we can reduce a little bit of our data usage. Now, at this point, you should have pretty much the basics of how to do VOIP with Godot in C#. So if you like this video, go ahead and hit that like button. Hey, you know, if you dislike this video, go ahead and hit that dislike button, because I'm here to make content for you guys. This video was a viewer suggested video, so if you have any suggestions, please leave them in the comments below, or jump on my GitHub, link is in the description. Create an issue inside of there, and I'll be more than happy to add it to my list. This entire channel is dedicated to creating content that you guys enjoy, so I need to know what you guys want me to make for me to be able to make good content. And hey, if you have any questions or comments, please leave them in the comments below, or jump on my Discord, link is in the description, and I'll be more than happy to help you out with any issues you might be having. But that is all I have for you guys today. So thank you so much again for watching, and I'll see you all next time. Thanks.